Welcome back to Cloud 42. I'm James. We are still working on the carbide insert hand scraper. Last time we finished machining the shank of the tool, including the taper for the handle and the pocket to hold the carbide insert. And this time we are going to make the clamp that holds the carbide insert into that pocket. This drawing shows the detail of the clamp end of the scraper. You've got the shank material coming in here with the step that we machined last time to hold the carbide insert. Carbide insert slides in here, and of course these are a different scale. And then there's a clamp that holds it down. Now the clamp is just made from a piece of flat bar, same material as the shank, but it has a couple of features that are important. There is a recess underneath, and you can see it here. It's only 10 or 15 thousandths. I'd have to go back and look at the drawing. Unfortunately, I didn't dimension that here. It's not very deep. It's just enough to make sure that the clamp isn't bottoming on the edge of the shank here, that the pad on the end of the clamp is bottoming on the carbide insert itself. The other thing here, besides the hole for the clamping, is there's a ramp on the top end here, and that ramp is actually curved, and this is more of an aesthetic thing. You absolutely would not have to do this. You could take this bar exactly the way it is, mill out a little bit of a pocket on the bottom, drill a hole through it, and you could use it exactly as it is. But this is a hand tool. It's something that I'm going to be handling a lot as I use it, and I want to have kind of the smooth surfaces, both for the aesthetics and also just for handling it. My hand scrapes across this. I don't want sharp corners on the front end as I'm pushing the tool through the work. So let's go over to the mill and get started. Again, I'm going to do this CNC. There's lots of ways you could do this. You could theoretically turn this, even with the nice taper and the curve, on a faceplate in the lathe, or just, do this freehand with a file or on a belt grinder. There's lots of ways to do this. Again, I got the CNC mill, so that's the way I'm going to do it. Let's go over to the mill and make the clamp. Okay, this is the stock, and we need to machine, just like we were doing with the shank and the tang, which you can see here, and the front edge where you can see the marks here. We want to machine this to full depth on both ends, and so the easiest way to do this is going to be here with the mini pallet, just like with the bigger part. And so I'll clamp it down, and unlike last time, I have the clamps ready to go. And in fact, I'm going to do the back one first here. There's a couple of things about this. This is a very, very tight setup because of the curves and the ramp that's going to be on this end. The part has to be positioned very closely to the way I planned the work holding in Fusion 360, because the tools get very, very close to the clamps. And so to make sure that happened, I modeled up everything in 360, including the clamps, and I took some measurements. So the edge of this clamp should be 3/8 of an inch from the end of this part. And if it's not, then we'll end up not having room to spot the hole here on the other side. Okay, that looks just about right there. And also, just like when we did the tang, and we need to dial this in and get it straight. Let me grab an indicator. That side's high, that side's low. Side's a little high, so let's give it a little tap. Okay, that's right at 0. If I go to the other end, half a thou. that is more than plenty for this particular part. Let me put another clamp on the front side here and just make sure everything is good and tight. Okay. That's good. Let me grab an edge finder and let's locate the end of the part. Okay, that's the left X, so we'll 0. So that's the right X, so we'll say divide by 2. And there it is, 0Y. And there is Y, divide by 2. And as usual, let me check the Z0, set it as well, using a 10 thou shim. Okay, that just gripped. So we'll set the Z to 10 thousandths with the offset. Okay, the first tool is going to be tool 8, which is our 1/4 inch carbide end mill, running at 1800 RPM. 4 flutes. Okay, we've got this all clamped down, ready to run. We've got a 4 flute carbide 1/4 inch end mill in here. We'll run at 1800 RPM, and we're going to machine both ends of this. We're going to actually cut the end curved and straight on this end and straight on this end, and then we're actually going to mill in some of the steps for the ramp, which we'll then come back and refine with a ball end mill before we drill the hole. Now, there's a little bit of a trick here. The way I have this set up, these clamps come up well above the normal clearance retract height in Fusion 360. And I say clearance retract because I can't remember if it's the clearance height or the retract height. But you have to get it set up so that the tool path will bring that tool up above these screws when you come across. Otherwise, you'll finish one side, pop up, and snap the tool off as it travels to the other end. And so in Fusion, I actually modeled the clamps and listed those as a fixture, so then when I simulated it, it came up and stopped and everything turned red and it told me that I was going to hit the clamp until I raised those heights. We should be good now. If not, you'll get a show when we snap off an end mill. Let's go to 1800 RPM and mill this thing. Okay, we got that roughed out. Next step is a ball end mill to smooth the curve on this end. Now this tool is only high-speed steel, so we're only going to run it around 1200 RPM. And we should just make a whole bunch of passes, 5 thou apart, to smooth out this end. Oh yeah, that's beautiful. That was worth the trouble. Okay, next we need a spotting drill to spot the hole there. And remember how I said this setup was tight? Well, it's tight. I actually just cut the clamp there. Clamp's mild steel, it's not going to be a big deal. Spot's in the right place. And the next drill to come through is going to be smaller anyway, so we should be good. Now I would say this is the same drill as last time, but it's not the same drill. This is a number 9 drill. When we did the shank, we used a number 21, which is tap size for 1032. But for the clamp, we need clearance size, so this is a number 9, which is clearance for 1032. And we're just going to push this through in one operation as well. No pecking, we're just going to shove it through there. And there we go, that's the clamp done. I'm very happy with how that turned out. A nice smooth edge. There's little marks from the ball end mill every 5/1000ths, but it makes kind of a nice little radial pattern. The next thing we have to do is we need to mill out a recess on the bottom of this. Okay, we've got the front side of this milled, the top and with all the curves on the sides. I got a nice little ramp there, which just turned out beautiful. Now we need to flip it over and machine the recess in the back. And rather than try to hang on to it or do anything with the mini pallet, I think since we're only machining the top edge of this, we should be able to just hold it in the vise. Okay, so we're going to machine down from the top 15 thousandths on this. Let's see how much clearance I actually have over the vise jaws. That looks like we're at about 21 thou. And there we've got the same 21 thousandths. And again, we're only going down 15, so that should be fine. That extra 6 thousandths clearance should prevent us from milling into the vices. Okay, let me grab an edge finder. Now because tolerances are so tight here and I only have about 6 thou to deal with, I'm going to do the Z0 with the actual tool we're going to use. And that's going to be tool 8, which again is the 4-flute carbide 1/4 inch end mill. Okay, I'm going to make sure I have selected tool 8 here in Mach 3 before I do the 0. And then I'm going to bring it down and 0 it as usual. Okay, just grabbed, use the offsets and set the Z to 0.1. Okay, and we're set to tool 8, so we should be good, and I'm looking, the Z minimum on the program is minus 15 thou. So we should be completely clear of the vise jaws. Let's spin it up and give it a shot. There we are, 15 thousandths recess. Now I'm just going to do a little sanity check here and make sure it looks like it's going to completely clear, and it does. Okay, and while this is in here, I'm just going to do a little deburring with Scotch-Brite. Way easier to do this now than to do it after it's out because these are so shallow. Okay, I think that's it. Let's take it over to the bench. Take a look. Okay, that is the clamp complete. I'm really loving the little parallel marks from the tooling, that curved ramp. I really love how that turned out. I got to do more contour milling on the mill. Should need to do a little bit of deburring on this, and it should be ready to assemble. Just going to use a small file here. Take the sharp edges off of it. Actually isn't much here. There's kind of sharp edges there, but it looks like I got most of that with the Scotch-Brite. Just touch the top and bottom of the hole to clean it up. Tiny little chamfer, just enough to be able to see it. Okay. Okay, that looks good. Recess in the bottom feels like about 15 thou, about what I was looking for. Let's put the whole thing together, or at least put the insert in, see how it works. That in like that. Okay, I've got the carbide insert, I've got the clamp, and I've got a number 10, a 1032 screw, and a number 10 washer. Feels good. Let me grab a wrench. Oh yeah, that pulls down nice and solid. Oh, very nice. That looks just like the drawing. Oh yeah. There I am, scraping a little bit of aluminum off. That is going to be beautiful. Well, I think that's it for the shank and the insert and the clamp. I think the next thing we need to work on is the handle and then the insert to go in the back, and we will work on those next time. If you're enjoying these videos, please give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.